Hello, welcome to the video on arcs and chords. This is our third example set C, and I'm going to go ahead and assume that you watched the lesson in the previous example set problems, just because that these particular problems that we're going to be looking at are going to be pretty involved. I don't think they're going to be overly complex, but you're definitely going to have to know the kind of the basics of what we learned in the lesson. So if you haven't tried those problems yet, that's where you want to start. So we have three circle problems, and we're told that A is the center of each one of these circles, and we have to answer some of the questions related to each one of the circles. So let's go ahead and start with our first problem. All right, so when you're given a situation like this, there's kind of a lot going on. So the first thing you have to do is study the problem, okay? So, noticing the problem, you say, okay, we have a radius here, another radius here. We have a chord, we have another chord. We have two perpendicular angle here, another one here. We have this length of this particular part of the radius is 3. So there's a lot going on. So what you want to do is key in on what the question's asking. Okay, so here we're asked to find the length AY. All right, so this is what we're looking for right there. And now what we have to do is start to really kind of paint a better picture and get more informed of what's going on here. All right, so we're told that the measure of xy, this arc right here, is equal to the measure of zw, this arc here. All right, so now recall from the lesson, okay, when you have two arcs that are congruent, what do we know about the chords? Okay, their respective chords. Well, here, this chord xy is going to be congruent also to this chord zw. Okay, remember, two congruent arcs have congruent chords. Okay, so if two arcs are congruent, their respective chords are congruent. All right, and that's going to be very helpful because we know that ZW, this chord here, is 8 units long. So that therefore we know that XY, okay, because remember XY now is congruent to ZW. All right, these are two congruent chords because their arcs are congruent. So XY is going to also be equal to 8 units. All right, so that's going to be very helpful. Let me go ahead and just erase this now. So this is going to be 8 units long right here. Now, the next thing I want to key in on is this perpendicular angle. All right, so now we have a radius, or not quite a radius, but a part of the radius or part of the diameter. Okay, it's on the same line that is perpendicular to this chord XY. Okay. So what do we know about a diameter or a radius or any part of those two? Okay, when it forms a perpendicular angle, when any one of those, a diameter or radius, forms a perpendicular angle with a chord, what's the situation? What can we imply? Well, the biggest thing is that this chord gets bisected. So in other words, this gets chopped in half. Okay, not only the chord, the respective arc also gets bisected. Okay, if this radius, if you will, would continue on through, it would bisect that that arc. But here we know that this chord is 8 units long. Okay, we already figured that out. So therefore, this will be 4 and this will be 4. Okay. All right. So let me get rid of some of this here. What are we looking for? We're looking for AY. We're looking for this distance here. So now I'm kind of honing in on this right triangle. I kind of see a picture kind of developing. So I know this length is 4. Okay, we just figured that out. And this length here, boy, it would be nice if we knew that length. Well, we do know that length. Okay. Remember that we have a theorem that says when you have two congruent chords, okay, two congruent chords are the same distance away from the center. Okay. That's another particular theorem. So already in this problem, we've already called upon probably at least, trying to think here if I can recall, but I'm thinking probably at least 3 of the theorems that we learned in the lesson. Okay, so because these chords are congruent, they're also the same distance away from the center. So this chord is 3 units away from the center. So this chord here is 3 units away from the center. So right now we have enough information to find AY. Or what you have is a right triangle situation, okay, a right triangle problem, where A is the center of the circle, and here's Y. Okay, this distance is 4. This is perpendicular, so that's a right angle. And this distance is 3. Okay, can actually probably draw this a little bit better. They don't kind of quite look like they're in proportion, but that's okay. As long as we know that the numbers are right, we have enough information to solve for AY. Okay, all we have to do is use the Pythagorean theorem. So this would be 3 squared plus 4 squared equals AY squared, or 9 plus 16 equals AY squared. So that'd be 25 equals AY squared. So now I'm going to take the square root of both sides. I get AY is equal to 5. All right, so now, once again, we solved what the question was asking for that length, AY. That's going to be 5. But the process we took was basically using all of the theorems that we learned in the lesson. Okay, so this is a fairly involved problem. You have to know those theorems. You got to know how to apply them. That's why I really kind of preface this particular video by saying, hey, listen, watch that lesson, try some of those more basic problems, kind of build yourself up to a problem like this that requires, kind of 3 theorems and the Pythagorean theorem. So I guess that would be 4, to get to the solution. All right, not difficult, but once again, just requires you to know to master some of those other fundamental skills. So let's move on to our next problem. Okay, so same thing. We're going to kind of study the problem before we start taking some action. So here we have a circle. We know that A is a center, and I have a chord going through the center, so that means this is the diameter of the circle, and we're looking for TV. Okay, well, if you notice, we have these 2 other chords, and they're forming a right angle here, and this is what I'm looking for, TV. So this could be, looks like to me right now, this could be a right triangle problem. So if you're thinking the same thing, then I think we're on the right track. Okay, so we know that UV, this distance here is 10. Okay, so that's the hypotenuse in this right triangle. And what else do we know? Well, we know that the measure of these 2 arcs are equal. Okay, so the measure of UT, this arc here, is congruent to TV. So once again, what do we know about congruent arcs? Okay, so if 2 arcs are congruent, that means their respective chords are also congruent. So this chord is equal to this chord. All right. So now we have a right triangle, and we know that these chords, or these sides of this right triangle, are also congruent. Okay. Now, we do have some additional information. We know that these 2 angles are equal, TUA and TVA. So that's this angle right here is congruent to this angle. So now you have enough information to solve for TV, which is just one side of this right triangle. So let me kind of draw it a little bit better here. Right, so here the hypotenuse is UVT. Okay, so here this is a right angle. And the hypotenuse is 10. And these sides right here are congruent. Okay, those are our chords, so they're the same here. So I'm just going to say, I'm going to represent the sides of these triangles as x, okay, because they are the same distance. And now I'm going to go ahead and apply the Pythagorean theorem to solve for x. Okay, in this case, x would tell me the distance of TV. So how do we solve for x? Well, let's use the Pythagorean theorem. Okay, so it'll be x squared plus x squared, right? Okay, these 2 sides of the right triangle, okay, square, I'm just using the Pythagorean theorem. So this side squared plus this side squared is going to be equal to the hypotenuse squared, which is 10 squared. All right, so now I'm going to get 2x squared. I'm just combining like terms, equals 100. Right now I'm going to divide both sides by 2. And I get x squared is equal to 50. And now simplifying this, I'll just go ahead and take the square root of both sides. So I'm going to get x is equal to the square root of 50. Now this is the correct answer. Okay. However, 2 things here. If you have your calculator, some of you are going to go into your calculator and find the square root of 50. And that's okay, but I really kind of want you to reinforce your skills to work with radicals. So the square root of 50 is equal to, okay, let me go and write it this way. The square root of 50 is equal to 25 times the square root of 2. Okay, those are the factors of 50. Okay, the square root of 50. So this would be 5 times the square root of 2. All right, so If you had to take this test without a calculator, this would be the answer I would be looking for. Okay, if you gave me this answer, I'd probably deduct maybe 1 or 2 points depending on how nice I felt that day. Okay, because this is not fully simplified. All right, remember radicals, kind of think of them as a fraction. If you give me a fraction like this, 30 over 40, okay, as your final answer, all right, is that the most simplified? No, you would want to give me 3/4, right? You would want to reduce that answer. Same thing here, okay? So when you're working with radicals, make sure you fully simplify those radicals. All right, let's go ahead and take a look at our last problem. Okay, so once again, we're going to go ahead and study the figure, and we see, okay, here I know A is the center, and I have a chord that's going through A, so that is a diameter, okay? And I have another chord here. All right, so say, okay, let me see what else is going on. What else can I determine? So now the distance of AZ is 2. I'm looking for AK, right? So let me just kind of erase this. I'm looking for this distance here, all right? So thinking to myself, if I'm looking for AK, it'd be nice if this was a right triangle, okay? AZK. If that was a right triangle, then I could, just use a Pythagorean theorem, but we just can't assume that's a right triangle. All right, we have to see if we can develop enough information to kind of prove that's the case. So looking at our additional information, we know that this arc here, HJ, is going to be equal to JK. So these two arcs right here are equal, okay? And if they're equal, let's think about it, okay? If they're equal, that means this entire arc, HJK, was bisected by this diameter, okay? Let's think about that for a second. So if HJ, that arc, is congruent to JK, that means it was bisected by this entire diameter. And that can only happen if the diameter is perpendicular to this chord right here, okay? Because this chord here is what is forming this arc. All right, so now I know that the arc itself has been bisected. I know these chords, so this chord here is also bisected. So we're kind of looking for some sort of justification to determine if this right here, I'm going to erase this part of the problem is a right triangle. And now we can see that it is because this diameter is forming a right angle with this chord. It has to, because this arc right here was bisected by the diameter. All right, so hopefully that makes sense. And if you're struggling a little bit, like I said, go back to the lesson, try some of the more basic problems. Okay, now with that said, let me erase this. Let's go ahead and, whoops, I didn't want to do that. We had our diameter right here. All right, so now let's go ahead and focus in on this right triangle right here. Okay, this right triangle. What pieces of information do we have in order to solve for AK? Well, I know that HZ is 6 in length, okay, 6 units in length. So this right here is 6. So therefore, this part of the right triangle is also got to be 6. Okay, once again, that chord was bisected, and I know that AZ is 2. So this is 2 right here. Okay, so kind of, hopefully, I know that this figure is getting a little bit crowded, but let's just focus in now on that right triangle that's going to allow us to solve for AK. Okay, so AK is what I'm looking for. All right, so this is Z. Okay, I know that HZ is 6, and I know ZK has got to be congruent to HZ, okay, because that chord was bisected. So therefore, ZK has got to be 6. I know that AZ was 2, okay, because I was given that from the beginning. So now I can go ahead and solve for AK. All right, once again, just a simple application of the Pythagorean theorem. So let's see, this is going to be 2 squared plus 6 squared is going to be equal to AK squared. Okay. All right, so if you haven't tried this, solve this problem, go ahead and see if you can actually simplify this radical, because there is going to be a radical we're going to get here. So this is going to be 4 plus 36 equals AK squared, or 40 equals AK squared. So AK the distance we were looking for is going to be equal to the square root of 40. Okay, but would I leave my answer this way? All right. Nope, you want to simplify it, and that'd be equal to the square root of 4 times the square root of 10, and that'd be 2 times the square root of 10. Okay, that would be the appropriate answer. Now, if you got yourself a decimal, you just want to double check on your calculator if you took 2 times the square root of 10 that you're going to get the same value. If you did, then you did the problem right. But if you're struggling with these radicals, this is where we can't leave algebra behind, our algebra skills that we learned. Okay, so these are some of the expectations that you're going to be kind of held to when you're doing geometry. So once again, if you're weak or struggling in any area, pause what you're doing. Don't get frustrated. Go back and study the lesson and review what you need to do. Like, for example, these radicals, if they're giving you a tough time, go back and study up on them. But if you got everything right here, you should feel very good about yourself, and keep working hard. We'll see you soon.